Hello and welcome to the course of manufacturing process eh, to the course of MSMP. This is fourth module and 23rd lecture. In this module we are discussing about the machining technology, and today in this machining technology we will be teaching about tool material. So first let's start our lecture with tool material. So in the last lecture, as we have discussed about the cutting tool. There are three type of cutting tool that we have discussed. There is single point cutting tool, there is multi point cutting tool, and there is double point cutting tool. And these cutting tools are mainly made of some material. That material is the function or as the mechanism, as we have already studied the mechanism of chip formation or mechanism of cutting. That in that cutting mechanism, what we have seen that due in that cutting mechanism we have seen that our chips the chips are formed due to shear action, and that shearing action is started by indentation. So what is important, that indentation is important, and this indentation can be achieved only and only if the cutting tool material is harder than the workpiece material. So from this we can have a idea that cutting tool material, what will be the cutting tool material? The cutting tool material should always be always have to be very hard material. So hardness is the important criteria for tool material. So there is likely like this, there are various cutting tool criterion, so that we will be studying in this lecture. So in details, the detailed study of tool material and what are the available tool material, what are the merits and demerits of that available tool materials, that we are going to study in this lecture. So let's start our lecture with lecture objective. The lecture objective of this lecture is to get an insight of the requirement to be a cutting tool material. That what I am saying just now, just a while ago, that the we have to know about the what is the requirement to be a cutting tool. So to be a cutting tool there are certain requirements, and the first and foremost of them is your the cutting tool material should be hard enough to indent, to have a indentation inside the workpiece. Now to understand, secondly, the second objective is to understand about different type of cutting tool material. So what are the different type of cutting tool material, that we will understand in this lecture. So let's start. So what is cutting tool? So start with the definition. So the definition of the cutting tool can be written as: cutting tools are wedge shaped tools. Cutting tools are wedge shaped tools which can be used. The cutting tools are wedge shaped tools which can be used. So the cutting tools are cutting tools. What is cutting tools? As I am saying, that these cutting tools are wedge shaped tools that is used in machining. That is used in machining are called cutting tool. So whatever may be the tool is, the tools which can be used in machining, the wedge shape or V shape tool which is used in machining is known as cutting tool. Now the cutting tool material must have some properties, such as, what are those properties? The properties are cutting tool material properties are the cutting tool material properties are hardness, toughness, to etc. And some of the example of the cutting tool materials, what are the some of the example of cutting tool materials? The some of the example of cutting tool materials are cemented carbide, diamond, high carbon, high speed steel, etc. These are the name of the some of cutting tool materials. Now we will see about the requirement to be a cutting tool material. the cutting tool materials should be harder than the workpiece. The cutting tool material should be harder than the workpiece. Hot or red hardness of the workpiece should be there. Hot or red hardness of the workpiece should be there. High toughness should be there. High thermal conductivity should be there. Low coefficient of friction should be there, and this cutting tool material should be easy to fabricate, weld and grind, and the cost of this cutting tool should be low, so that it can be very easily available, so for being the cutting tool material, as I am saying, that main condition is that cutting tool material should be harder than the workpiece, and it should have hot or red hardness, high toughness, high thermal conductivity, low coefficient of friction, and it should be easy to fabricate. It should be easy to weld and grind, and the cost should be low, and it should be easily available. If a material fulfills all of these conditions, then we can make cutting tool. We can shape that material to the specific shape by grinding to have a cutting tool. So these are the requirement to be a cutting tool material. Now the typical cutting tool materials are high carbon steel, high speed steel, cemented carbide, stellite, ceramics, diamond, and cubic boron nitride. So these are your typical cutting tool material. Now these cutting tool materials are mostly used in the machining operation, and these are used for specific different machining. But the concept is, whenever we need to machine harder material, means if we have to machine cast iron like that material, that is hard material, that hard material should be machined by harder cutting tool. Okay, so as per the hardness, this list of high carbon steel, high speed steel, cemented carbide, stellites, ceramic, diamond, and cubic boron nitride, this is the list of increasing hardness. That means the high carbon steel has the lowest hardness in between these cutting tool materials, but above that, high speed steel has more hardness than high carbon steel, and cemented carbide will have more hardness as compared to high speed steel. Stellite has more hardness than all of these three material. And ceramics has also, it has more hardness than all of the above four materials, cutting tool materials. Diamond is the hardest material that is available in nature. And cubic boron nitride, this cubic boron nitride is the hardest material that can be that is man-made. So cubic boron nitride is a material that is man-made material, but diamond is the naturally occurring hardest material. So these are all the cutting tool materials. We will now see about the different this type of the one by one. We will discuss about all of these cutting tool materials, and we will discuss about the selection of the cutting tool materials also. So high carbon steel. What is high carbon steel? High carbon steel is plain carbon steel. The material is a plain carbon steel that have carbon percentage up to 1.5%, and these carbon are not suitable for production work. So whenever the carbon steel has carbon percentage of 1.5%, they are very not suitable for any production work. So with this much carbon percentage, that means your 1.5% carbon, the iron or steel cannot be used for producing or for manufacturing any product, any steel product. So that's why and those carbon steels are somewhat hard. they but these high carbon steels are less costly, easily forgeable, and easy to heat treat. And they but these are the advantage of high carbon steel. And the disadvantage or demerits of the high carbon steels are they lose their hardness. That means hardness will be reduced above 300 degrees Celsius. And so that's why for high speed or high cutting speed or heavy duty work, due to high cutting speed, friction generation, there will be high friction in the tool workpiece interface. So at that tool workpiece interface, what will happen, due to high speed due to heat generation, that cutting tool material will lose its hardness and easily chip up or and easily wear off. So this cannot be used for high speed cutting or heavy duty work. It is only used to limit to cut wood or some soft material. So for cutting of wood and some soft material, this HCS or high carbon steel material is used. Now for high speed steel, high speed steel is a special alloy of steel which increases the strength and toughness, wear resistance, cutting ability, etc. So what is high speed steel? High speed steel is a special alloy of steel which increases strength, toughness, wear resistance, and the cutting ability of the workpiece. So this is HSS tool. And the HSS tool materials in HSS material, the tungsten, chromium, vanadium, cobalt, and molybdenum, these are used as alloying element up to 25%. So the hardness that is achieved in the HSS tool mainly came from the alloying elements such as tungsten, chromium, vanadium, cobalt, molybdenum, etc. So this HSS tool can operate 2 to 3 times higher temperature than a high carbon steel. So the operating temperature range for HSS tool can be taken as as 600 to 900 degrees Celsius. And to retain the cutting ability, this HSS tool retain the cutting ability up to the operating temperature, retaining the rated cutting ability. That means the rated cutting ability can be found up to the temperature 567 degrees Celsius. And this HSS has high hot hardness and high wear resistance. High wear resistance means it can be used for number of application. Number means it can be used for large number of large number of part produced. So whenever the more number of the part can be produced or more number of workpiece can be machined by using HSS tool as compared to other tool. So this can be achieved by a property that is called wear resistance. This HSS tool is used to manufacture complex shape tools such as reamer, drill, taps, etc. So HSS tool material are used to manufacture complex shape tools. Next is cemented carbide. The cemented carbide or sintered carbide are the tools that are used for mass production. So for mass production we need a tool which has more life, and that tool life means how many times or how many hour one tool will run without any need of regrinding. That is called tool life. and this tool life for cemented carbide is very large, so that's why we can use it for mass production. So if we use for mass production, if we use HSS tool, then what will be the problem? Then in the mass production, that is continuous line of assembly is there, that means the production is happening in a continuous way. So now if we have to change the tool after 3 or 4 operation, or after 3 or 4 part is produced, then the whole system will be very slow. So that's why what we need to use some material, we need to use some cutting tool, that is cutting tool material that can withstand this continuous loading, and that can be hard enough, or that can be hard enough, so that it can be used for mass production. So cemented carbide is one of these tools, and these cemented carbide tools are made by using tungsten, titanium with carbon, and the compound is combined with the cobalt and sintered at a furnace at 1400 degrees Celsius. So what is sintering? Sintering means, what we do for sintering, for making this cemented carbide, we just add tungsten, titanium and carbon along with cobalt in the powder form, and that powder is shaped in a mold, and bounded by using some binder, and that whole cake like structure is placed in a furnace, and by in the furnace they are somewhat baked at 1400 degrees Celsius. By baking that sinter in a furnace, what will happen? The powder particles will join with each other and make one solid piece. That piece is known as sintered carbide or cemented carbide. So this is the process how this cemented carbide happens, and this cemented carbide tools possess a very high degree of hardness and wear resistance. So as I am saying, the hardness and wear resistance is one of the important criteria for being a cutting tool material. So in this case, in case of cemented carbide, this has very high degree of hardness and wear resistance. Cemented carbide can operate, these cemented carbide materials can operate at 5 to 6 times higher speed than HSS, and these cemented carbide, as they are made in the in lab or in some workshop. So that's why these are very much expensive, and they are available in the form of insert of different shapes. So what do you mean by insert? Insert is nothing but there is another tool holder. That tool holder part or the shank part, this insert, as I am describing the geometry of a single point cutting tool, there I have discussed about the body part, the shank part. So and the cutting point or the cutting part, the main part which is involved in cutting is only the cutting point where our flank face, rake face is there. So that is the most important part. In the insert form, what will be there in the insert? That part, that only that rake surface, that cutting point are made, and that insert is inserted into a shank. That shank is mainly made of plain carbon steel, and that plain carbon steel shank, in that plain carbon steel shank, these insert are inserted, and they create a cutting tool that can be used for machining. This is the cemented carbide. For stellite is a non-ferrous alloy that consists of cobalt, tungsten and chromium. As this name suggests, cobalt, tungsten and chromium, these alloy or these metals are very hard, and so they possess the alloy of this possess hardness also. So stellite is a non-ferrous alloy that consists of cobalt, tungsten and chromium, and the tools that is made by the stellite can operate 2 times faster than HSS tool, and they can retain this stellite piece that can retain its hardness at very high temperature also, and these materials have better tool life than HSS. Now for ceramic, in case of ceramic, the tools are made of ceramic material that are capable of withstanding the high temperature without losing the hardness. They are more wear resistant than cemented carbide tools. They are not used for rough machining work because they are more brittle and have low bending resistance. While machining with the ceramics tool, coolant is not required for. So in case of ceramic machining, we can use dry machining technique. So that dry machining, detail of dry machining we will be studying in the next lecture, that is cutting fluid. And this can be very useful. These ceramics can be very useful for machining of for high speed operation with the desire to have good surface finish. So that's in that case the ceramic materials are create very good cutting tool. Now there is diamond. Diamond is the hardest cutting tool material. It offers high wear resistance but low shock resistance due to its brittleness. The diamond have low coefficient of friction, so it can be used for high grade super finishing. Though the super finishing operation can only be done by using diamond, and diamond tools have low thermal expansion, high heat conductivity, poor electric conductivity, and it is brittle in nature. And this diamond tool give good surface finish. And next, the artificial material that is produced in the laboratory using high pressure and temperature is known as cubic boron nitride, and this cubic boron nitride is hardest artificial material, and this hardness, it has hardness can be its hardness can be next to the diamond, and CBN tool can be used for machining of difficult to machine material with higher accuracy and productivity. These CBN tools are also very expensive tools. So this is all about your cutting tool. If you have any problem, you may ask in the live class. Thank you.